Hi! In this video, we're gonna learn about heat. We know that heat can be thought of as the energy that's being transferred between substances because of the difference in temperature. So heat, the quantity of the heat being transferred during a temperature change will depend on what type of material or what type of substances changes the temperature. And of course, it depends also on the quantity of the substance and the size of the temperature change. So there are a lot of factors that we have to consider so that we can determine accurately how much heat gets to be transferred from one substance to another during a temperature change. Now, I have mentioned that because of the difference of the substances, then the quantity of heat will matter as well. And this is because each substance has what we call specific heat. So specific heat is actually defined as the amount of energy required to be able to raise the temperature of any gram of any substance by at least 1 degree Celsius. And because of this definition, we can deduce the common units for specific heat, which are, it can be joule per gram degree Celsius. It can also be configured so that we can convert our Celsius to Kelvin, so that can be expressed as joule per gram Kelvin. Or the joule can also be converted to a unit of energy, which is calorie. So it can also be calorie or cal per gram degree Celsius. So these, if you see these, any of these units that you see here on the screen, then that's the unit of your specific heat. And specific heat are very unique for every substance. Usually there will be a table of values that will be given to you in order to get the specific heat of a material. Now, I want you to memorize an equation. To be able to find the amount of energy gained or lost in any temperature change, there is one formula that you need to remember, and that formula is Q, that's small letter Q, is equal to mc delta T. So there are three quantities multiplied here. We have mc delta T. So delta T is one whole thing. So let's now learn what this means. Q is actually the quantity of heat that's either lost or gained in the process of the change, in the process of the transfer. If the energy is gained, then the Q will be positive. If the energy is lost, then the Q will be negative. Now, let's relate the Q to the delta T, because it's the delta T that will dictate whether it will be negative or positive. Now, delta T, let me skip here. Delta T is here. Delta T, we know that the delta will always mean change. So change in temperature, and change is always the difference between the final temperature minus the initial temperature. The moment you subtract the final minus initial temperatures, you get the delta T. Now, if the Q is negative, that means your delta T will be negative. In that case, that's the loss of energy. We expect our final temperature to be lower compared to the initial temperature. That's why your Q will be negative in case the temperature drops, because again of the loss of energy. However, if the energy is gained, we expect that the final temperature is higher than the initial temperature. Therefore, the delta T, the difference of the two, will give you a positive value. Therefore, your Q will also be positive. So that's how the delta T relates to the Q, or the amount of energy. The other variables that you see in this formula are M and C. M stands for mass, so that's the amount of your substance, and C is your specific heat, which is what we defined a while ago. And To get the specific heat, if you're going to use it for the problem solving, you need to refer to the table of values for that, which will be given to you. You need not memorize that. So let's now be ready to apply this to a certain problem solving. So let me flip my notebook and let's go to a very level one simple problem of Q. Let's read the problem together. We have a 5.5 gram, G means gram, of liquid water is heated from 298 Kelvin to 348 Kelvin. How much heat is absorbed in the process? So, by looking at this problem, if you want to pause it and read it again, please do so. If you want to copy it on your notebook, then please feel free to pause this this video so that you can do it step by step, okay? So the very first step in every problem solving is you need to identify the given. So what are the given variables in this problem? So we have M, the mass, which is the 5.5 gram. So every time you see a G, that's automatically your mass, so M. Next, it says it's heated from 298 Kelvin to 348 Kelvin. Kelvin is the unit of temperature, and the 298 is the from, so that means that's our temperature initial, so that's our T initial, 298, to 348 Kelvin, so 348 Kelvin is our final temperature. Next, you are asked for how much heat is absorbed in the process, and we know that there's one variable that's missing. In order for us to solve for Q, we need to know the C of liquid water. So the C of liquid water, I looked at it in a chemistry textbook. I use the C for liquid water expressed in joule per gram Kelvin because my temperature is expressed in Kelvin. So I use the one that has the Kelvin in it, so I don't have to keep on converting. So I got this from the book. The complete value of C for liquid water is 4.18 joule per gram Kelvin. The dot is just to emphasize the separation of gram and Kelvin. So joule per, the slash is per gram Kelvin. So now I have all the complete values. Now I want to make sure that I solve my delta T right away, because anyway I'm given my initial and final T, so I can solve for my change in temperature, delta T, right away by subtracting final minus initial. So my final is 348 Kelvin, my initial is 298 Kelvin. So final of 348 minus 298 Kelvin, my delta T is 50 Kelvin. So now all my values are ready for me to be able to solve what's required, which is the heat absorbed in the process. So that should be Q. So now I'm going to go to the third step of solving this problem. I need to solve now the problem. So I begin with writing the formula of Q. Q is always equal to the product of M times C times delta T, in which, because my values are already in my given, so all I need to do is just put them and substitute them in the problem. So I have M, which is 5.5 grams, times the C of 4.18 joule per gram Kelvin, times the delta T. I'll now use the ones I subtracted, the difference of the subtraction, that's 50 Kelvin. Now, I can cancel units that's not important here, or that can be cancelable. So the per here, the gram and the Kelvin are both in the denominator. So the Kelvin on the other side can be canceled with the Kelvin on the C, and the gram here and the gram from the M will all be canceled out. Again, because the gram and the Kelvin from the C are all in the denominator, and these two are on top, so therefore I can just cancel them out. Now, leaving my joule as the remaining unit, which is logical because the final unit of Q has to be joule. So now I'm ready to put this in the calculator. So I'm just going to multiply my 5.5 times 4.18 times 50, I will get the values in the calculator, 1,149.5 joule. This is a bit of a big value. Usually, if it's a very big Q value, you need to convert it to kilojoule. So to convert this to kilojoule, all you need to do, because a kilo has 1,000, so all you need to do is divide this by 1,000. So let me transfer my equal sign there. By dividing that by 1,000, I can express my final answer in kilojoule with 2 decimal places. So I can have my final answer as 1.15 kilojoules. And that is my final answer for this particular problem. Hang in there. There's another problem that I want you to watch after this that will give us a leveling up of the concept. Bye-bye.